So welcome everybody to this latest A2 video on 162 Math, and in this video we'll be continuing with trigonometry with a focus on finding the arc length and sector areas in radians. Now when working with radians, the formulas to find the arc length and sector area are as follows. So the arc length is theta r, so that's what this red line here is. So if, let's just label these, so if this is r and this is theta, this red line can be calculated by doing theta r. And likewise for the area of a sector, which is this section here, again if we had r representing our radius and our theta representing our internal angle, then this area is going to be what's stated there, which is half theta r squared. Now just a little reminder that when working in degrees, now these obviously need to be in radian mode, so when using these formulas, your calculator doesn't necessarily need to be in radian mode. Just the only thing that needs to be in radians is your angle, because obviously the only time that radians has an effect is when you're using the trig ratios. So when you are doing this, it's just simply going to be whatever theta is times r. Your calculator doesn't need to be in radian mode. So let's just, instead of using these formulas, your calculator does not need to be in radian mode. Now again, in terms of a quick refresh with regards to working in degrees, so in degrees the formula for arc length is going to be theta over 360 and times 2 pi r. And the way I always remember it is 2 pi r is connected to the circumference and the arc is connected to the circumference, and so that's how I remember it. For the area in degrees, this is going to be equal to theta over 360 times pi r squared. And then you can go from there. Now, if you have got no idea in terms of the formulas for arc length, you can use that substitution of that degrees into radians is theta, pi over 180, and then you can just go on and simplify it. But again, if you can try and remember that these two formulas for arc length and sector area in radians, it just makes your life a whole lot easier. Now again, just a quick reminder or quick note is that for trigonometry or SOHCAHTOA trig and for scalene triangles using the sine rule and the cosine rule, that the formulas are exactly the same. So theta can either be given in degrees or it can be given in radians, but when you're dealing with trigonometry in the form of SOHCAHTOA or cosine, then that's going to be the same. The only thing you do need to make sure that when using any trig ratio, make sure your calc is in radian mode. So for working out sectors and areas, sector areas and arc lengths, not a problem. You can have your calculator at any mode. But whenever you start using a trig ratio, and you're working in radians, always make sure your calculator is in radian mode. And when you're working with degrees, make sure it's in degree mode. So let's have a look at these example exam style questions. Now all of these questions are taken from past AQA papers and are relatively the same. So once you've gotten a technique and once you've done a few, you will notice that they are all mostly asking for the same thing, and the layout of each of the questions are very, very similar. So let's have a look at this first one. So it says the diagram shows a sector OAB of a circle with centre O and a radius of 20 centimeters. The angle between the radii OA and OB is theta radians. And the first part of the question is asking us that the length of the arc is 28 centimeters. Show that theta equals 1.4, and it's worth 2 marks. So for the first one, let's just get a decent colour pen. And so for here, for A, we've got that the arc length, which is theta r, is equal to 28 centimeters, and we know that the radius is 20, so it's theta times 20. So therefore theta is going to be 28 divided by 20, which equals 1.4. And there I've proved what they've asked me to prove. Then for B, it's asked me to work out the sector area. So for B, so the sector area, and again, it's always worth practicing just writing down the formulas just to make it more instinctive. So it's a half r squared theta or half theta r squared, whichever floats your boat. And then substitute the numbers in. Well, we know that r equals 20. We know that theta now is 1.4. So substitute numbers in, that the area is going to be equal to 0.5 times 1.4 times 20 squared. And again, if I type that all into my calculator, I get an answer of 280 centimeters squared. And there we go. So then moving on to part C. So part C then says that the point D lies on OA, the region bounded by the line BD and the line DA, and the arc AB is shaded. The length OD is 15 centimeters, and the first question is asking us, for part I, is find the area of the shaded region, giving your answer to 3 sig fig. Now with the shaded questions, you tend to find that the shaded area equals the big shape minus the small shape. Now in this case, my big shape is the arc and the small shape is the triangle. And so what you need to do is find these two separate areas and then obviously clearly subtract it. Now in terms of this, for CI, so in terms of working out the area of the triangle, well, for this, what I'm going to do is, because I don't know the height of that triangle, I'm going to use the formula of AB sine C. Now, in terms of labeling the points that I know, well, A is going to be 15, B is going to be equal to 20, and C, the angle is 1.4. Now, we need to again make sure that we're in radian mode for this when working it out. So, substituting the numbers in, what do I get? Well, I get 0.5 times 15 times 20 times sine of 1.4. And again, remembering that we're supposed to be in radian mode, so typing that in, we should get 147.81745595, which again, round this up to 3 sig fig, is going to be 148, and the units are going to be centimeter squared, and that's to 3 sig fig. Then for II, so if the question is asking is to use the cosine rule to work out the length of BD. So to use the cosine rule, we've got that A squared equals B squared plus C squared minus 2BC cos A. And I always tend to put this in brackets. So in terms of labeling this up, we get this is my B, or this is going to be capital A, the angle. This is going to be C, and A is what I'm trying to find. So substituting the values in, I'm going to get 15 squared plus 20 squared minus, and then bracket 2 times 15 times 20 times cos of 1.4, and that gives me an A squared value 523.0, and it's a few extra numbers, and then square rooting that, I get 22.9 centimeters. And again, that's to 3 sig fig, and there is my final answer. Now again, with these types of questions, it's always worth showing that they're worth 3 marks each. Try not to sort of be lazy in terms of the working out that you're doing. So here I need clear evidence that I've used the correct rules and that I've correctly substituted the values in. So you don't necessarily need to write down the formulas, but you do need to show evidence that you've used them and you've correctly substituted the values in. And also just check for any sort of specification in terms of how we want the answer written, because that'll be worth 1 mark within itself. So looking at example 2, it says that triangle ABC shown in the diagram is such that AC equals 8 centimeters, CB equals 12, and the angle ACB is theta radians. And the question is saying that the area of the triangle ABC is 20 centimeters squared. And the first part's asking is very similar to the previous example, show that theta equals 0.43 correct to 3 sig fig. So in terms of this, let's just note down the key bits of information. So in terms of labeling this out, now obviously we're working out the area and not being given the height, so I'm going to be using that the area is equal to half AB sine C. Now from this, I'll just write A here. Let's just label down the key points. I'm going to use A equals 8, B equals 12, and theta equaling theta. And it tells us that the area is 20. And so let's just write that. So substituting the values in, what do I get? Well, I get that 0.5 times 8 times 12 times sine theta is all equal to 20. Now in terms of rearranging this, I get sine theta equals 5 over 12, and then in theta is therefore going to equal the inverse of that, which is 0.403. 0.402 big QED. Now in terms of B, it says use the cosine rule to find the length of AB, giving your answer 2 sig fig. So again, just have to do exactly that. So in terms of B, let's use different color, green. So here for the cosine rule, we're finding the length. So it's going to be A squared equals B squared plus C squared minus 2 lots of BC cos A. And again, just labeling on the diagram, this is going to be my A, C, that. So I've got capital A, this is my B, this is my C. And again, substituting numbers in, what do we get? Well, we're going to get 12 squared, A squared equals 12 squared plus 8 squared minus 2 lots of 12 times 8 times cos of, which theta we've worked out as being 0.43. Then A squared is going to equal 33.5, and then we just need to square root that answer, which is 5.79. That's to 3 sig fig. That's my final answer. Now the important thing is with A squared is obviously don't round that up to 3 sig fig, because obviously it may affect your final answer in terms of that. Now in terms of for actually B, I've not read the question myself, which is a clear instruction because it does say to 2 sig fig. So therefore the answer is going to be, scrap that, is going to be 5.82 sig fig, which again, easily done. I'd like to say I did that on purpose, but I'm sure you know that has not been the case. So moving on to part C of this particular question, it says that the point D lies on CB such that AD is an arc of a centre circle C and the radius 8 centimeters. The region bounded by the arc AD and the straight line DB and AB is shaded in the diagram. And the question is asking us, first part of the question is asking us to work out the length of the arc AD. Now for this, for part CI, so let's just write CI, so arc length, and we're dealing in radians, is going to be theta r. So from this we know that theta is 0.43, so that's going to equal 0.43 multiplied by the radius, which is 8, because that's what it is. The 12 refers to the triangle, always make sure you're using the right number, and that gives us 3.4, and that's to 2 significant figures. And why is it 2 significant figures? Because I've actually read the question this time and it does tell me so. Now in terms of part 2, it then says work out the area of that. Well, the shaded area, well again the shaded area is the big shape minus the small shape. Now in this, the big shape is the triangle and the small shape is the arc. So in terms of this, what we need to do is, well, we know that the area of the triangle is 20. So this here is 20. So what we need to do then is work out what the area of the arc is, which if I just do it all in one line, that's going to be 0.43 times 0.5, just mixing up the formula, but we're just multiplying, so it doesn't make a difference. So using a half theta r squared, that gives me an answer to 6.24 blah blah, which rounded to 2 sig fig is going to be 6.2, and the units are going to be centimeters squared, and that's 2 SF. So example 3 says that figure 2 shows the shape ABCDEA, which consists of a right angle triangle BCD joined to a sector of ABDEA of a circle with radius 10 centimeters and centre B. Now ABC lie on a straight line with AB equaling 10 centimeters. Given that the size of the angle ABD is exactly 1.9 radians, point A is asking us to find the arc length of DEA. So for this, what we just need to do for part A is just simply plug it into our formula. So the arc length is going to be equal to theta times r, which is going to be 10 times 1.9, which gives us 19 centimeters. Now for part B, what it's then asking us to do is to find the perimeter of the shape of ABCDEA. Now obviously I know what E is because E is now 19 centimeters. So the only two sides I've then got to work out, which is going to be DC or CD and BC. Now for this, what I'm going to have to do is use SOHCAHTOA trig, because obviously it's a right angle. So this here is going to be equal to pi minus 1.9. Now I'm going to use the angle of pi minus 1.9 rather than actually working that out, simply because just to improve the accuracy of my answers. So in terms of looking at this, if I label this as x and this as y, so first of all, working out what x is, well, that's going to be using, well, that's going to be my opposite, this is my adjacent, and 10 is my hypotenuse. So to find out what x is, what I've then got to do is I'm going to be using O and H, which is therefore going to be sine of pi minus 1.9. Remembering to make sure my calculator in radian mode is going to be equal to x over 10. So therefore x is going to equal 10 times sine of pi minus 1.9. And if I plug that into my calculator, making sure again that I'm in radian mode, because I'm using sine, so I've got 10 times sine of pi minus 1.9, and that gives me an accurate answer of 9.463000877. Then working out what y is, so here I'm going to have to use cos, so I've got cos of pi minus 1.9 equals y over 10. So then from this we get y equals 10 times cos of pi minus 1.9, which gives me a y value of 3.232895669. So then from this, what I can then do is then work out what the perimeter is going to be. The final perimeter is going to be 10 plus 19 plus x, which is 9.463. Now because they want it to 1 dp, I'm just going to go a few decimal places extra, plus y, which is 233. And if I type that all into my calculator, 10 plus 19 plus 9.463 plus 3.233, I get a final answer of 41.696, which rounded up to 1 dp gives me 41.7 centimeters, and there my final answer. Now looking at our fourth and last example, the question says that the diagram shows a sector OAB of a circle with centre O and a radius of 10. And the first part, for part A, saying that theta is 0.8 radians, and it's asking us to work out the area of the sector. So for part A, area is equal to half theta r squared. So substitute numbers in, I get 0.5 times the theta, which is 0.8, multiplied by 10 squared. Now again, if I type that all into my calculator, well, what do I get? Well, I get 40 centimeter squared. Then for BI, the question is asking me to work out the perimeter of the sector. Well, the perimeter, P equals, it's going to be 2r plus the arc length. Now 2r is going to be 10 plus 10. And the arc length, which is going to be theta, which is 0.8, times a radius, which is 10. And so typing that all into my calculator, I get an answer of 28 centimeters. And then for the final part, it's asking me for the perimeter of the sector OAB is equal to the perimeter of a square. Find the area of the square. So for this, what we need to do then is do 28 divided by 4, which is 7. And what this then tells me is the length or the side of the square. And if you've got a square of 7 centimeters going either way, then the area of the square is going to be 49 centimeters squared. And there's my final answer.